x. So find the points on the curve. So we are given the curve y equals 2x cubed plus 3x squared minus 12x plus 1. So find the points where the slope of the tangent line is horizontal. Okay. I don't have to graph this function, but I know how to graph it because it's a cubic function with a positive leading coefficient, so it has to look like this. It doesn't have to have these terms, but if it does, obviously the function is increasing till this point. It's decreasing till this point, and then it's again increasing. Every time we have the function has a turn, assuming it's differentiable there, right? I have to look at the situation, right? But assuming it has a turn, every time it has a turn, if first it has a positive, like this one, first it has a positive slope, then it has a zero slope, and then it has a negative slope. If it's like this, first it has a negative slope, then it has a zero slope, and then it has a positive slope, assuming this is not a corner or a cusp. So obviously the horizontal tangent happens when the function has a max or a min. This is for future, because we are going to use this a lot, this idea. So if it says find the points where the slope of the tangent line, or point, who knows, we'll see in a minute, of the tangent line is horizontal, all we have to do is set y prime equal to 0. This is the equation we have to solve, because this gives the slope, and if we're talking about horizontal lines have slope 0. Obviously, at this point the slope is 0, at this point because the tangent is horizontal. So I bring down 3, multiply by 2, so I have 6x squared, plus I bring down 2, multiply by 3, so I have 6x, and minus 12 because x prime is 1, and when I differentiate 1 I get 0, and I have to set this equal to 0. I mentioned this, but allow me to mention it again. Factor and simplify should always be in the back of our minds. Of course, I'm going to divide by 6, again, to make the equation as simple as possible. And when I do that, I get x squared plus x minus 2. If I can remember how to factor, or if it takes more than 30 seconds, I will use the quadratic formula. But in this case, it's not a problem. I factored x squared plus x minus 2, sx plus 2x minus 1. Of course, we get two solutions, negative 2 and positive 1. They're asking us to find the points. If I'm asked to find the points, then the x values are not enough. You don't have to name them differently. I could have used p or q or whatever, but you have to find the y coordinate. So, although it's not a big deal, I just want to refresh your memory how to do this with the graphing calculator in y equals. Clear if you have anything else. And let's put in this function 2x cubed plus 3x squared and minus 12x and plus 1. And then go to second and table, and plug in negative 2 and 1. Negative 2, enter, 1, enter. And I got 21 and negative 6. That is so much better than starting from scratch twice or using other features. It's up to you. Any questions? Okay, finally, let's talk about exponential functions. So we're going to look at, for now, e to the x. We also have general exponential functions where this is a specific situation. This is a natural exponential function. But we will also talk about the general situation in which we have any base raised to x. If you remember, the base in this situation for the exponential function can be either greater than 1, not 1, or between 0 and 1, not 0, not 1, not negative. Okay, so we have a few formulas that we acquired so far. We acquired the power rule. X prime is 1. We know the square root of x is 1 over 2 the square root of x. And a constant times a function prime is the constant times the function prime. And that's basically it. We're going to add this one to the list. I don't want to give the result. I want us to work on it. So the function that we want to determine the derivative for is this. So we're going to use the definition, which is the limit as age approaches 0 from the difference quotient e raised to x plus age minus e raised to x divided by h. Okay, so of course I'm going to plug it in, and of course I'm going to get 0 over 0. No question. That is definite, the answer. Okay, so what do I do next? So what I do next is I want to refresh your memory on this piece. So let's take it aside for a moment. And here's what we get. I hope you remember that when I multiply a base raised to a number m times a base raised to a number n, I copy the base, and what happens to the exponents?
You add the exponents.
Very good. M plus n. But this is the same going reverse. So if I see e to m plus n, I should be able to write e to m times e to n, because that's where this is coming from. It's the sum of two exponents. If it's a sum of two exponents, it definitely has to come from a product of e of those two exponents. So that's my next step. So limit as age approaches 0. Tell me again, how do I write the first piece?
E to the x times e to the h.
Excellent. Please remember this. This is a dynamic relationship, meaning it goes both ways. If you are given this, we have to be able to come up with this. If we are given this, we have to be able to come up with the left-hand side. Because now you're going to tell me, and I know you're going to know what I'm going to do. So I'm going to continue here. Do not drop the limit operator. I saw in several of your tests, you drop the limit operator, and I mentioned please don't, because it makes no sense. It's not correct. Okay, so what do you think I'm going to do next?
You get rid of the e to the x.
Very good. I'm going to factor out e to the x. Excellent. So you notice now one thing, I hope, and this is very important to understand, that we only talk about a limit when age approaches 0. This piece, this one, does not depend on age. It's a constant. So every time I calculate a limit, when we calculate a limit from a constant times a function, we are allowed to take the constant, if it's a factor, we're allowed to take the constant in front. We discussed that limit law in chapter 2. So that's exactly what I'm going to do. E to the x is a constant, does not depend on age. So now I have limit e to the h minus 1 over age when age approaches 0. Unfortunately, we do not have enough information at this point. We will in the next chapter, very soon, maybe even in this chapter, because I don't wait normally till the next chapter for a particular theorem. So we don't know how to calculate this, but we still have our calculators, so we can still, for now, let's put in this function. Of course, not the limit. We're going to put in this function e to x. There is no, it's not x, it's x in the calculator. E to x minus 1 over x. Do not forget to put parentheses around the numerator. So in y equals, left parenthesis, second and e, make sure you put x, come down from the numerator, depending on your calculator, minus 1, close the parenthesis, and divide by x. So e to the x minus 1 divided by x. Number 1, we can graph the function and see how it looks like. Or, let's go to second and table. And I'm going to punch in numbers as close as possible to 0 from either side. So let's say 0.1, which is huge, negative 0.1, which is still huge, but negative 0.000001 and positive 0.00000001, and you tell me what is that limit. What does this equal to?
The limit of this function would be positive 1.
Excellent. Great job. So then what is the derivative of the exponential, the natural exponential function? Anyone? So we started here, and we got here.
1.
E to the x times 1.
Exactly. This is the nicest function on the planet. The sweetest function possible. I don't have to do anything. E to the x prime is e to the x. That's it. I just didn't want to give you the result and say, how come? Because I always have students asking, well, wait a minute, what trick is that? So I show them the trick. So I wanted to show you before you ask. Okay, so let's take a look at a function like, let's say y equals x to the third plus 4x squared plus 5 e to the x. And we want to find dy over dx. I'm going to go back and forth to all different notations because sometimes we need this one, sometimes we don't want this one. So I want us to get used to them. So, of course, you're going to tell me 3x squared. You're going to say plus 8x plus 5e to the x. And that is it. Any questions? Any questions? Now, one thing that I would like to mention, and then we can move on, is what is called the normal line. You are going to encounter this, and it's important. So let's say we have a function. This is f of x. Yes, of course, I have a point. And yes, it's p. And I can draw the tangent line at that point, p. So this is tangent at p. And the line that is perpendicular to this one at that same point, this is the normal line. If I'm given a function, so let's say f of x x squared minus x to the fourth, we are given a point 1, 0. And let's say we are asked to find the equation of the tangent line and the normal line. Find the equation, or equations if you want, of the tangent and normal lines at, of course, 1, 0. Only because I want to refresh your memory on perpendicular lines and parallel lines. These two lines are parallel. This has slope m1 and this has slope m2. Obviously, m1 must be identical with m2 if they are parallel. But if they are perpendicular, let's say this is slope m1 and this is slope m2. The way I present it to my students is, I think the easiest way is to say that, does anyone remember the relationship?
Isn't it the inverse of the slope of the
The negative inverse. It's a mouthful, but if you remember it like this, which is the same thing, it will always be easier. I can say that m1 is the negative multiplicative inverse of the other, or I can say the product is negative 1. The product of the slopes. Cross multiply and you get this. It's up to you. It doesn't matter to me how you remember it. They mean the same thing. But for me, it's easier to say the product of the two is negative 1. Coming back to our problem, I have to determine the slope of the tangent line, and only then I can determine the slope of the normal line. In order to determine the slope of the tangent line, I will find the derivative, plug in 1, and then after that I'll find the slope of the normal line. So then f prime of x is 2x minus 4x cubed, and f prime of 1 is the slope of the tangent, which is 2 minus 4, which is negative 2. If one slope is negative 2, then what is the slope of the other one? So the slope of the normal must be 1/2. Why? Because only negative 2 times 1/2 is negative 1. And now I can determine the equations. So for the tangent and for the normal, y minus y1 equals the slope times x minus x1, y minus y1 equals the slope times x minus x1. So for the tangent, this is -2. The point is the same, 1 comma 0 for both. 1 comma 0 for both, but this one is 1/2. And after I simplify, I get that y equals -2 x minus 1, or y equals -2x plus 2 as being the equation of the tangent line. And then y equals 1/2 x minus 1, or y equals 1/2 x minus 1/2 is the equation of the normal line.